On the top question, we have a square and we have three positive charges named Q at three of the locations. So we have one on the top left, one on the bottom left, and one on the bottom right. And this is square, so each side is equal to each other. So the question is, which one of the arrows, A, B, C, or D, shown represents the direction of the net electric field in the center square? So net electric field. So as you remember, when a question asks about electric field, the first thing you do is to put our measuring device at that location. So our measuring device at the center of the square. So we are going to put a measuring device, which is our positive test charge. It's always positive at the center of the square. And now we have to look at the net electric field. So to look at the net electric field, let's just look at individual electric fields first. So because of the positive Q here, it's a positive charge. Our positive test charge is positive. So at the center, so these repel each other. So at the center, our arrow is going to go this way. I'm drawing it a little off center, so I'm not drawing on the A, B, C, D, B, and D. And then let's look at this charge. So now they repel again. So at the center, repel. This also has electric fields, but that's not the question, so we are not concentrating on that. And then we have a third charge. Again, they repel. So it looks like that. Now as you can see, this arrow and this arrow cancel each other because they are equal and opposite in direction. They are equal because the distance from the middle to each of the diagonal Q's are same. So they have equal in magnitude and opposite in direction. So they cancel out each other. So what is left is this arrow here, which is A. So the answer would be A. Let's look at the second question. We have a negative Q, a negative Q, and a negative Q. And the question is, what is the net electric field at the center of the square again? So let's look at the center of the square. Draw a positive test charge. Now, because of this negative Q, this is negative, positive, they attract. So at the center, arrow goes like that. That's our electric field line. And then because of Q here, again, it's an attraction. And then the Q here, positive, negative, looks like this. And then we can see that this arrow and this arrow, the electric fields are magnitude equal but opposite in directions, so they cancel each other. So what we end up is this arrow, which is C.